Welcome to the introductory video for Processor-Based Functional Test for DDR, or PFTDDR for short. This short video will cover the DDR calibration or tuning on a SABRE Lite board, followed up with a DDR testing after applying the tuning results. The testing will employ a variety of test methods. So let's get started by covering the system setup. We start with a host PC with ScanWorks installed and connected to a remote instrumentation controller, or RIC-1000 for short. The RIC-1000 is connected to the SABRE Lite JTAG port. Now we start the ScanWorks application. The project configuration was preloaded from the SABRE Lite. Other tutorials will cover that setup step by step. Examination of some of the hardware connectivity details shows that we're connected to the RIC-1000 and that the JTAG clock is set to 30 MHz. Now by selecting the DDR test and tune action, we'll launch the developer. Within the developer, you'll see three main areas: the project area, the task area, and the console settings area. We start by selecting Connect. This action connects the JTAG controller to the SABRE Lite JTAG port. Then a target agent, or IP, is downloaded into the internal RAM of the i.MX 6. By selecting Run, this will execute the task sequence whereby the parameters for configuring the DDR memory controller and the settings of the DDR memory configuration are transmitted to the registers on chip. Once the setup is complete, the next step in the sequence is to exercise the memory. This is accomplished by a comprehensive memory test. The test is conducted to ensure that the configuration data was correct. Once this step passes, we can begin the tuning exercise. Briefly, let's look at some of the settings. First, in the DDR settings, we need to select the DDR configuration setting to automatic and the memory type to DDR3. Setting to automatic allows for the calculation of the static values. Next, we set the Ddr frequency. The DDR clock period is automatically calculated from the frequency setting. The next data is derived from the SABRE Lite schematics. From the schematics, we see the number of chip selects on the SABRE Lite is 1, and the number of memory devices per chip select is 4. Finally, we set the CPU frequency. That is all the data required for the tool to configure the memory controller. For the 1 GB of memory on the SABRE Lite, it will take an hour and 20 minutes. Obviously, this is not a production test. Don't worry, the video doesn't capture all the training output. Let's quickly review the calibration sequence. First is the one-time force of the ZQ calibration, then the right leveling calibration, followed by the DQS gating, the read data and write data calibration. We start the DDR calibration by selecting DDR Tune and right mouse clicking the Run. The first step in the tuning process conducted by the IP is to train the right leveling parameters by adjusting the right DQS relative to clock. Starting with byte lane 0, a seed value is set and then searching outward from the seed value, first increasing the value and then decreasing the value. At each value change, a stress test is performed. The DDR5 training will display memory test errors during the training process. These errors are expected when the specified 5 parameters are outside the operating range for the target. Once we have completed the search for the upper boundary of the right leveling on byte lane 0, we begin the search for the lower boundary. Once the lower boundary is located for the right leveling on byte lane 0, the right leveling window is printed to the console. So the calibration process continues for each of the byte lanes 0 through 7. Now as we finish the right leveling parameter tuning on byte lane 7, the final DDR5 timing results are displayed. The data reported is for the 3 measurements on the 8 byte lanes. This is the operating window found for each 5 parameter. Next, a summary of the 5 tuning registers values are displayed. The next step is to calibrate the read data bit delay and the write data bit delay. At the completion of this step, the data is provided for the RA-LAT and the WA-LAT register settings. The final step is to update the DDR settings from the tuning results. As we can see, there are many changes that are required. With the tuning or calibration process complete, we have one more action. and that is to verify the changes made during the tuning. This is accomplished by performing a comprehensive memory test. So let's recap.